So that's era. That's an entering era for all kinds of applications, school applications. In fact, you can use it for any kinds of applications. Just fold it. You can carry it anywhere if you want to charge it. That's it. So what are the disadvantages for it? Polymers have high resistance and are not good conductors. That hurts us. And because of poor electronic behavior, yeah, that's the reason. In fact, that's the only drawback of that's the reason it drops back the efficiency of it. The excitons are, I'm going to discuss about it. The excitons cannot have enough mobility to get back to the electrodes, all the metal electrodes. So that's the reason the efficiency is pretty low. But they are trying to get that. The efficiency, the current efficiency is almost like 8%, but they say they are anticipating almost like 15%, probably by 2012.
There are some conducting polymers.
Yeah. There are PSS, P2HDs, PCBMs, and DuPont is one of the companies which is vigorously working on conducting polymers. They have conducting tapes too. Alright, these are nothing but a blend of all the structures. A single structure. Here's just a small template. So bottom layer would be actually a glass slide, and then on top of it would be the ITO or ethylene oxide, and then on top of it would be the active layer or the conducting polymer, like PET PSS, polyethylene dioxide. And upon that, we need to have some kind of metal contact in order to capture those chemicals, capture those charge carriers. And then we can have them. In fact, these are nothing but the band gap for organic electrons. Like we have the band gap structure for semiconductors, inorganic ones. These are like band gap structure for organic. LUMO, that is lower unoccupied molecular orbital, and HOMO is higher occupied molecular orbital. These are in fact this model is similar to the band gap model but an organic version. Okay, now they came out with this is our glass slide, ITO, PDAT, NDAT, and then the metal contact. And these are the heterostructures or bulk projections, and these are came out to be good efficient ones. Glass slide, the ITO, ethylene oxide, and then the blend of the mixture of PDAT and NDAT, and the metal contacts. So they are trying to increase the efficiency factors. So, okay, what exactly does happen in a photoconductor, or what exactly does happen in this organic solar cell? Okay. Once sunlight falls onto that, okay, we do have absorption of radiation. That's one of the factors. It absorbs as much as radiation it falls into it. The next step would be once it generates, and like we have that the light photon energy breaks the silicon bonds. It do break the bonds up here and then generate the charge carriers. Those are called as excitons, or the hole and electron pair. It tries to break that, dissociate those plates, and then try to inject those carriers so that they can have enough power to move to the electrodes. Now we have N-type and P-type in the middle, and we have all the metal electrodes on top and the bottom. So we're trying to give enough energy to those carriers or the charges to transport to the electrodes so that we could capture them and generate electricity, and then carry transport and the recollection charges of electrons. That's what is our model. Alrighty, so what exactly, or how can it be factored, or how can we manufacture it? Okay, we just need apart from all the other ions, beam and all that stuff, we can also manufacture with a solution processing method. That's what we are doing up here. Spin coating, by using any spin coating machine, you can just do that. Or airbrush, in fact, we can do it with artistic airbrush too. Air gun, artistic gun. Yeah, and also dip coating, or you can just dip your glass side into that, and then probably you can just have it on the other side. Screen printing, screen printing is just like what I have discussed about inkjet printing. It's just like newspaper, you can just roll it. And also thermal evaporation for electrodes, that's what we're working on. In fact, I guess we need to add on another one, spray coating. We do have also that. So all these are cheap methods, what we can do in order to give a less production cost and we're getting more of this. And in fact, the pollution of here is also very less. In fact, zero pollution compared to the silicon. So that says that where exactly we're standing. The NREL, in fact, it is the only first agency to have been working on the solar cells rigorously. We are way ahead from any other agencies. If you look at University of Maine, this is organic. The red ones are the organic. In fact, if you could compare with the organic, in the beginning, the silicon was almost like 1%. In fact, the first silicon solar cell which was made was 1% efficiency. It was just 1%. So right away in the first attempt, we could get that thing. But probably as research is going on, NREL stands up here, and Berkeley is somewhere around 6 to 8%. Sorry, 4. But the current one is like 8% for what they have gained in Alpha technologies. The best one is multi-junction concentrators. Like these concentrators are they have better efficiency and they better concentrating power. They can absorb all the light, whatever it falls into that.
Now, when you say absorbing all light that falls onto it, if it's absorbing all the light, wouldn't that be 100%?
Well, that's what is the criteria. Like the conducting polymers cannot capture all the light. If it has to capture, okay, if silicon even can't capture all the light, it can capture only 20%. That's the reason the efficiency is still running at 26%.
Right.
So, if in fact the major thing is with the mobility of the charge carriers, the electrons doesn't have enough energy, in fact the holes to get back to the metal contacts. That's the exactly. So the only solution for this would be different blend of structures, different blend of materials. Probably soon they might come up with another Nobel laureate will come up with another kind of application. Okay, this kind of thing polymer may be best useful, have better efficiency, better absorption, and cheaper too. That's what they do. Sure.
So that all of the energy that comes in that's not and then converted into electrical energy is lost in the form.
Yeah, exactly.
So the system. So is that an issue?
Exactly.
That is an issue. How to how to get the heat out of the system so that it doesn't damage the polymer. Is that an issue?
No, it's not the issue with the
That is
damage.
not an issue.
What for the polymer? Inorganic is
Inorganic.
That is an issue.
For silicon.
inorganic. That's why they are making thin film. What are the same question? Thin film. What about
I'm sorry?
heat pollution?
Yes.
Okay, heat pollution. Now, are we not producing enough heat out of refrigerators? Are we not producing any heat out of our car? Even the fuel cells have that, but we are glad that it's not making any pollution. Carbon pollution. That's what, in fact, as I said earlier, USA stands first in carbon emissions. We are trying to cut down on those carbon emissions. Those are really harmful than what we have is heat pollution. We get heat out of everything. Now I'm using light up here. That's producing heat. I'm not complaining more on that as I'm complaining on carbon emissions.
That's any case of giving heat, right?
Yeah.
So where is the heat pollution?
Yeah, exactly. That's right. In fact, I got a supporting answer.
I have a question about that. Well, in all actuality, it's also causing the heat to, if the heat is being reduced because of the too many photons being absorbed, why can't we also harvest this heat in lieu of harvest?
Let me correct you. It's not the heat energy, it's like photons.
But the heat is being produced after, because we're going to take in so much photonic energy, and then we have heat. So can you possibly?
Oh yeah, in fact, as Dr. Batra was discussing about the smart grid was power electric, exactly. We can convert that heat energy to electricity.
Along with that, so
Exactly. And like it's all like combination or encapsulation of all the devices. Okay, we might come up with some kind of good application, a paro, a piezo, as well as solar. We might utilize all the energy and you are this electronics energy.
Now thermal sources are coming. Thermal sources. What do you like sources? Thermal sources are coming. Thermal.
So what if we manage to have enough energy? Like to use the energy to draw back up, so instead of draw how that implementation.
Okay. Well, I have been to one of the. In fact, if you are familiar with Nexus Energy Center in Huntsville, they have designed. In fact, they have installed these solar panels during the recent tornadoes, and they're trying to power up Southwest Huntsville and Hillsborough, other counties. But yeah, there are families in Huntsville who have been using solar panels since 20 years. They are just saying that we have spent almost $100,000 just on their solar panels. So that's not the issue for that because energy. In fact, if I go through that EROEI, that is energy return on energy invested, that is you just getting it almost like after 3.6 years. So okay, now they're trying to reduce that year, probably 3.6 to the current is like 2.7 years. Get back that energy, or get like that investment in 2.7 years. That's not bad idea.
Now garden lights everybody has. Garden lights, old one, they also sell. You don't need wire, you don't need anything. There's a battery inside, they charge it in the morning, the night you get light, automatic. See, they are there.
Ashok,
Yes, ma'am.
when you got polymers and stuff, you talk about biodegradable stuff. What's the, like, for example, the shelf life of these polymers and
Okay,
stuff like that?
these might, in fact, these currently, okay, the one which we make in our lab are probably efficient probably a week, and then these they went up with the new ones. These are probably efficient for almost 6 months.
Okay, now does the heat affect that?
No.
Breakdown?
No. In fact, all these solar cells they have a maximum up to 1,000 hours of utilization, but they're trying to increase that. So
how can you get back and forth?
I'm sorry.
Like, how can you get back your investment in
But
your solar cell last 6 months?
no, I'm comparing with that silicon ones. Now, after spending almost like $100 or $250 on that, so just spending $5. So that's what.
Well, in all actuality, the silicone lasts longer, say for 10 years, compared to having to buy new flexible panel every 6 months.
Okay. Would you like to have something like a heavy thing on your car and travel with that, or you want to have something like a flexible thing?
Most people don't like to replace things, they'll go with the heavier.
Yeah, in fact, but the research is going on so that they don't want to replace all that. They can have that for a permanent thing. But okay, if you want to get something, you can do something.
How exactly would you extend the life of these organic materials?
Yeah, in fact, that's the only thing with the excitons. What I'm talking about. If the excitons can have enough energy or enough juice to get back to this metal, of course, we have good efficiency.
Okay.
So it all depends on the materials. We need to have, as I said, if any noble light from up here could come out with some other kind of conductive polymer, probably we can do that.
Actually, you will see that there's so many commercial devices has come. Bag.
Yeah,
So
solar
you put a
bag.
bag and then so cell.
You can
Charge
just- yeah,
the
laptop.
cell phone. So many are there now. So many are there. The organic sources.
So then, so part of all these is to have polymers that have better quality for what we need for more of the energy being efficiently converted into energy, into the electrical energy, as opposed to going into photons. So you don't want to generate heat.
Yeah, exactly.
You want to heat.
Probably we might use another photoelectric thing,
Yeah.
and then we might use that heat energy too. So that, probably that's a good idea.
It has been done. It has been done. Just now, last month it has been done. Because the polymers are biodetic also. Biodetic means when you put the heat, we get the crack.
But
Same
now-
polymer is used inside.
But Batra, probably heat is going to be one of the elements one of the features that's going to lessen the lifetime. And that's what we're talking about, how quickly or how often you have to replace the solar cell. And if you can generate less heat, that would probably impact on longevity.